Hello everyone, and welcome to what is going to be our final video in our Calculus BC series here. Topic 10.15 or 10.15, representing functions as power series. So we're going to talk a lot about different problems in this video here, but before we do that, let's start by finding a geometric power series centered at 0. So example 1 says find a power series for f of x equals 4 over x plus 2 centered at 0 and state its interval of convergence. Okay, so first thing we probably need to do is write out our function. And let's do the first four derivatives here. So negative 4 x plus 2 negative 2, 8 x plus 2 negative 3, negative 24 x plus 2 to the negative 4, and one more just for good measure here. That would be 96 x plus 2 to negative 5th. All right, and then f of 0 would be 4 over 2, 2. F prime of 0 would be negative 4 over 2 squared, so it would be 1, I believe. And then f double prime of 0, so 8 over 8 would also be 1. This would be negative 1, I'm sorry. And then f triple prime of 0 would be negative 24 over 16, so negative 3 halves. And then the fourth derivative at 0 would be 96 over 32, or 3. All right, so now when we write our power series out here, we're going to go ahead and use our Taylor series format. So f of x equals f of c, which is 2, plus f prime of c, which is negative 1, times x minus c, plus f double prime, which is 1, times x minus c squared. Well, c is 0, so we can just go x squared, over 2 factorial, plus negative 3 halves, times x cubed, over 3 factorial, plus 3x to the 4th over 4 factorial. All right, so now let's simplify this down a little bit, make it look a little bit better for our work here. So we got 2 minus x minus c, or I guess we just do minus x since c is 0. So 2 minus x plus x squared over 2 minus 3 halves x cubed over 3 factorial, so minus 3x cubed over 2 times 3 factorial, plus 3x to the 4th, I don't know why I wrote x to the 4th there, this is 4 factorial, over 4 factorial. All right, so it's the first 5 terms of that. If we wanted to simplify that a little bit more, the first 3 terms are good. The fourth term, would be x cubed over, the 3's cancel out, so 2 times 2, which would be 4. And then this one would be x to the 4th, the 3's cancel out, so 4 times 2 would be 8. All right. Okay, so then our power series looks like it's going to be that. So let's see if we can come up with a general term for that. So obviously we're multiplying by negative 1 each time, as it's an alternating series. So negative 1 that is 0, negative 1 to 1, negative 2, negative 3, and 4. All right, and then it's just going to be x to the nth power as well. So x to the 0, x to the 1, x to the 2, x to the 3, x to the 4. And then denominator seems to be just powers of 2, right? Now, I know you might be thinking, well, there's no powers of 2 in the first one, but really there is. What we're going to do here is 2 to the n minus 1. All right, so this one would be 2 to the negative 1, which comes up to be 2 for the first term. And this would be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So you can see that would be our nth term there for our power series. Okay. As the example stated, this really here is going to be a geometric power series. So geometric power series, we want our for it to converge, we want it to be less than or equal to 1. So if we can rewrite this in geometric form here, if I write it like this, and divide everything by 2, I would get 2 over 1 minus negative x over 2. And that's our geometric sum form, as we know it. Okay, so that means the first term is 2, and the radius, the r value is negative x over 2. So to be convergent, this would have to be, the absolute value of that would have to be less than 1. So I have negative 1 less than negative x over 2 less than 1. If I multiply everything through by negative 2 there, I would get 2x and negative 2, or I prefer it to be written like this. So that would be our radius of conversion for that problem. Okay, now let's talk about differentiating a series. All right, so the first one here says, let f of x equals sine of x. What is f prime of x? All right, so f prime of x. So first, let's start here with what is the series for f of x? Okay, so the f of x series, that's one of the ones that we talked about recently that we should kind of just know. It'd be a whole lot easier if we just kind of knew it. All right, so that's going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial forever. All right, and then as a series, we can write that like this. All right, so we're going to differentiate that. We can do it in two different ways. We could differentiate this, or we could differentiate this. Either way, it's going to be very similar here, right? So f prime of x would equal 1. Now we're differentiating the second one. It's going to be 3x squared over 3 factorial plus 5x to the 4th over 5 factorial plus minus 7x to the 6th over 7 factorial. Right now, if I simplify that a little bit, right, I would get 1 minus x squared over 2 factorial, because the 3's cancel out, plus x to the 4th over 4 factorial, because the 5's cancel out, minus x to the 6th over 6 factorial, because the 7's cancel out, which looks surprisingly like the power series that we know as cosine of x. All right, now we also could have differentiated our nth term as well. If we differentiate our nth term, when we differentiate, this and this are just constants, so we don't differentiate that. Really, all we're doing is we're differentiating this, okay? So if I was differentiating that nth term there, I would get negative 1 to the n plus 1 over 2n plus 1 factorial. And in differentiating, we get 2n plus 1 times x to the 2n. Simplifying, I'll put that there. Simplifying that, we can have negative 1 to the n plus 1 over 2n plus 1's will cancel out, leaving me with 2n factorial, x to the 2n, which this happens to be the nth term for cosine of x as well. Okay. Number 3, let h of x be the function represented by this series. And write the first 3 terms for h of x. And then write the first 3 terms in general term of the series for h prime of x as well. All right, so this question here, we're looking at a power series, x to the n over n squared. First question is really easy here. Write the first 3 terms. So h of x, now this is going to be an approximation, because remember, if we're doing the first 3 terms, it's an approximation for h of x. So if we put 1 in, we would get x to the 1 over 1, which is just x. Put 2 in, we get x squared over 2 squared, which is 4, and then x cubed over 3 squared, which is 9. So there's the first 3 terms. Done. Okay. Now it says, write the first 3 terms in general term for h prime. All right, well, first of all, let's take h prime of x here. So remember, we're differentiating this. We're not differentiating the n squared. So the n squared is going to be n squared. In the numerator, we can do nx to the n minus 1. That's it. That is our differentiation of the series. So for h prime of x, the first three terms of that, we can differentiate this if we wanted to, or we could take the first three terms of this. It doesn't matter. It should be the same. So it's going to be 1 plus 2x over 4 plus 3x squared over 9. And we can simplify those a little bit if we want to. Plus, and now this is our nth term right here. Like I said, we could definitely simplify these a little bit if we want to, but for right now, this is good enough for what we need to do here. All right, number 4, let f of x equal this series here. Write the first three terms in a general term for f prime. Okay, so again, we can just simply go right to the terms and take their derivative. So f prime of x will be 3 minus 4x plus 15x squared over 3 factorial. All right, now the nth term, or the general term, remember, all we're doing is differentiating this crazy looking term here. We're just going to copy everything down. It does not involve an x. Of course, I wrote an x when I said it. And then differentiate the x part of it, which is n x to the n minus 1. All right, now can we simplify that? Yes, we can a little bit, but again, for right now, we don't really need to do that. That's fine. Okay, for a written question, that is an absolutely acceptable answer. All right, question B says, let k of x equal 1 to x of f of t dt, write the first three terms in general term for this series, k of x. Okay, so k of x is going to be the antiderivative of our three terms. So it's going to be 3x squared over 2 minus 2x to the third over 3 plus 5x to the fourth over 4 times 3 factorial, which would just be 4 factorial if we wanted to write that. Okay, but plus, now our nth term, again, now we're just going to integrate this. Okay, so again, all of the n parts of this, we just leave as is. And then we integrate the x to the n part. So that would be x to the n plus 1 over n plus 1. Now, could we rewrite that and simplify that a little bit more? Yes, we could. But again, for our written question here, this is an absolutely acceptable answer. All right, so some operations with power series here. You can see what we can do with some power series. We are allowed to multiply a power series by a constant. All right, we are allowed to square a power series or cube a power series, whatever, and we are allowed to add or subtract different power series together as well. Okay, the operations described above can change the interval of convergence for the resulting series, however. For example, in the following addition, the interval of convergence for the sum is the intersection of the intervals of convergence of the two original series, as you see down here below. All right, example 5, Maclaurin series for a composite function. Find the Maclaurin series for each of the following functions. Be sure to list the first three non-zero terms. All right, so we have sine x squared. Again, this would really benefit us if we knew the sine x series from before. Instead of having to build it every time, if we just know that, it's really, really going to help us out. Okay? Now, all we're going to do here is we're going to put, basically, we're going to put x squared in everywhere we see an x. That's it. That's all we are trying to do for this part. So, if sine x is that, all right, and I want sine of x squared, we're just going to put an x squared in everywhere we see an x. So x squared minus x squared cubed over 3 factorial plus x squared to the 5th over 5 factorial minus x squared to the 7th over 7 factorial. All right, now can we simplify that down a little bit? Yes, we can. So x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial plus x to the 14th over 7 factorial. All right, now the nth term for that, we can write that out. It's alternating again, so negative 1 to the n. All right, and this is going to be x to the, now let's figure out the powers here, 2, 6, 10, 14. That's going to be 4n plus 2. And then denominators are 1 factorial, 3 factorial, 5 factorial, 7 factorial. That is 2n plus 1 factorial. Okay, and then for part B, same thing with cosine. Now again, it would really, really help if we knew the cosine of x power series. So that'd be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Now if I want to find cosine of root x, I'm just going to put root x in everywhere I see an x. So 1 minus root x squared over 2 factorial plus root x to the 4th over 4 factorial minus root x to the 6th over 6 factorial. Simplifying it, 1 minus x over 2 factorial plus x squared over 4 factorial minus x to the 3rd power over 6 factorial. And then our nth term here is just going to be, again, we're alternating, so negative 1 to the n. All right, and this is going to be, look at x to the 0, x to the 1st, x to the 2nd, x to the 3rd, so x cubed over, basically, you got to think here, this is 0 factorial, 2, 4, 6 factorial, so 2n factorial. Number 6, we're talking about multiplication of power series now. All right, we have e to the x times sine x. All right, so first, it would, again, really benefit if we knew these two series. This is 2 of the 4 series we talked about recently in our last video. That would be very helpful if we knew them. All right, so e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. All right, so now what we want to do is we want to multiply these series together. Okay, so therefore, e to the x sine x is going to be, now we're just going to distribute all these terms to all these terms. So 1 times this plus x times that plus x squared over 2 factorial times that again, and definitely running out of room here. We can stop there for now. I think you get the picture at this point, but it does keep going forever. Now, if we simplify this down, we would get 1 times this power series, so it would be that, plus x times this power series, so we'll have to write this out here, x squared minus x to the 4th over 3 factorial plus x to the 6th over 6 factorial minus x to the 8th over 7 factorial, which I screwed up, that's 6 too, that's supposed to be, that doesn't change, it's still 5. Plus, and then if we distribute this x squared over 2 factorial, we get x cubed over 2 factorial minus x to the 5th over 3 factorial, 3 times 2 would be 6. So 2 times 3 2 factorial times 3 factorial plus x to the 7th over 2 factorial 7 factorial minus x to the 9th over 2 factorial 7 factorial. All right, so what we're trying to do here is we're trying to find the first 3 non-zero terms. Okay, so that's just going to be x. Now, our x squared, we have just 1x squared there. And we have 2x cubed, so it's going to be minus x cubed over 3 factorial plus x cubed over 2 factorial. So you're saying, well, that's 4 terms. Yes, I realize that, but this is technically 1 term right here. Okay? So we could do some work here to combine that into 1 here, but we get a common denominator. So if you want to do that, this would be 6 and this would be 2. So our common denominator is 12. So we have x plus x to the 2nd minus this would be 2x cubed over 12. This would be 6x cubed over 12. So 6 minus 2 would be 4x cubed over 12. And that would be our first 3 terms. All right, what about if we want to do some division?